Humanoid robots, building machines in our own image. For centuries, humans have imagined artificial beings that look and act like us. From ancient myths of mechanical servants to modern science fiction, the idea of humanoid robots has long reflected both our ambitions and our anxieties. Today, that imagination is rapidly becoming reality. Humanoid robots are no longer confined to laboratories or cinema screens. They are stepping into factories, hospitals, and even our homes. At a basic level, humanoid robots are machines designed to resemble the human body in shape and movement. They typically have a head, torso, arms, and legs, allowing them to navigate environments built for people. This design is not merely aesthetic. Human spaces, from staircases to door handles, are optimized for the human form. A robot that moves like a person can, in theory, operate more easily within these spaces than one built on wheels or tracks. Recent advances in artificial intelligence, sensors, and motor control have dramatically accelerated humanoid development. Companies such as Boston Dynamics and Tesla have demonstrated robots capable of walking, lifting objects, and performing repetitive tasks with increasing precision. What once appeared clumsy and mechanical now seems almost natural, if slightly unsettling. Watching a humanoid robot stand up or regain balance triggers a strange sense of familiarity, as if the machine is borrowing something deeply human. This reaction highlights one of the central questions surrounding humanoid robots. Why do we insist on giving machines our own shape? Psychologists suggest that humanoid design encourages trust and intuitive interaction. We read faces, gestures, and posture instinctively, and robots that mimic these cues feel easier to understand. At the same time, this resemblance can provoke discomfort, a phenomenon known as the uncanny valley, where almost human machines appear eerie rather than friendly. Beyond psychology, the rise of humanoid robots raises profound social and ethical concerns. Supporters argue that these machines could transform healthcare by assisting the elderly, supporting people with disabilities, and performing dangerous tasks in hazardous environments. In aging societies, humanoid robots are often presented as a partial solution to labor shortages, particularly in care work. Critics, however, warn of deeper consequences. If robots look and behave like humans, where do we draw the line between tool and companion? There are fears that emotional attachment to machines could replace human relationships, or that widespread automation may worsen economic inequality. Questions of responsibility also emerge. If a humanoid robot causes harm, who is accountable, the manufacturer, the programmer, or the owner? Culturally, humanoid robots function as mirrors. They force us to confront what we believe makes us human. Is it intelligence, emotion, creativity, or morality? Each new robot invites comparison, and each comparison reveals our assumptions about ourselves. As humanoid robots continue to evolve, their significance may extend far beyond practical use. They are not just machines performing tasks, they are symbols of a society testing the boundaries between human and artificial life. In building robots in our own image, we may ultimately be learning more about ourselves than about technology.